At the end of this chapter, you'll be able to describe the general purpose and layout of the fuel system. Identify and locate the components of the fuel system. Describe the layout of the fuel system and identify its subsystems and interface. Explain the operation of the fuel system main components. Identify and explain the controls associated with the fuel system. Identify and explain the indications and annunciators associated with the fuel system. Welcome to the chapter Fuel System. This lesson is comprised of the following chapters: the fuel tanks, the ventilation system, the engine feed components, the fuel quantity measurement, the refuel and defuel system. You'll also learn about the associated fuel system alerts, details about the electrical supply, and the maintenance panel. Here is the table Acceptable Fuel. Note that the use of JP4 or Jet B is prohibited. Let's start with the fuel tanks. Each wing contains one tank, which is formed as an integral part of the wing, and each tank has a feeder compartment with a capacity of 200 liters. The feeder compartments are, under normal conditions, always full of fuel in order to maintain the engine feed in case of negative or lateral load factors. The capacity of each tank is 3,185 liters. This is equal to 2,500 kilograms, which is the total quantity of usable fuel in each tank. The maximum permissible imbalance is 730 kilograms. Each tank has an additional volume that allows a 2% thermal expansion without spillage. To provide access to the interior and to essential equipment, each tank is equipped with 2 access doors. The doors are located on the upper wing skin at each tank extremity. At the low points of each tank, a water drainage is installed. Water drainage can be performed at up to 3 degrees ground slope. In the left feeder compartment, a temperature measuring device is installed. The temperature is displayed on the fuel panel just below the crossfeed push button. Pay attention to the scaling. Observe that there is no scale above 0 degrees Celsius, since positive temperatures up to 57 degrees Celsius are not limiting. Now assume that the fuel temperature is minus 40 degrees Celsius. Which indication do you expect? Look at the indication again. To sum up, the labeling shows only negative temperature values. In the FCOM Section 2, Limitations, you'll find the minimum fuel temperatures. The purpose of the fuel ventilation system is to ensure a positive air pressure in the tanks during the entire flight envelope. Each fuel tank is air vented through an individual vent duct and a vent float valve that are connected to a 100-liter surge tank. The surge tank is located in the outer wing section and is connected to the atmosphere via a flush NACA inlet. The NACA inlet is a low-drag air inlet designed to avoid ice obstructions. Any fuel entering the surge tank is collected and directed back to the wing tank via the vent duct. The vent system also protects the tanks in case an accidental fuel spillage occurs during refueling. The wing center box over the fuselage is not used for fuel storage. It shelters 2 fuel pipes for engine crossfeed and tanks refueling. The box is vented and drained to prevent fuel vapor concentration. Now let's have a look at how fuel feeds the engines. During normal conditions, each engine is supplied with fuel from its associated wing tank. For example, the left engine is fed with fuel from the left wing tank. You can monitor the fuel consumption for each engine via the fuel flow and fuel used indicators located in the center instrument panel. In the feeder compartment of each fuel tank, one electrical fuel pump and one jet pump is installed. The jet pump is a Venturi tube activated by the high-pressure fuel from the respective engine hydromechanical unit, short HMU, which will be explained in detail in the chapter Power Plant. The high-pressure fuel flow responsible for activating the jet pump is called motive flow and is controlled by the motive flow valve. Each electrical fuel pump is able to supply one engine during the entire flight, while one electrical pump and the associated jet pump are able to supply both engines during the entire flight envelope. In normal operation, the electrical fuel pump is used only to start the engine. 30 seconds after the jet pump output reaches a certain pressure, it automatically takes over the engine fuel supply, thus de-energizing the electrical fuel pump. As soon as a fuel low level is reached in one tank, or the pressure of one jet pump drops below 5 psi, the respective electrical fuel pump is automatically activated to supply the engine. Note that a remaining fuel quantity equal or less to 160 kilograms in the tank represents a fuel low-level situation. To prevent fuel imbalance, a cross-feed valve allows both engines to be fed from one side or one engine to be fed by either tank. The valve is controlled by an electrically operated actuator. When the crossfeed valve is opened, both electrical fuel pumps are automatically activated. By manually switching off the electric fuel pump of the tank with less fuel, the motive flow on the respective side is also stopped. And it is possible to use the fuel from the fuel tank with a higher level to feed both engines. Observe that when using the cross-feed, some fuel transfer from the tank where the electrical fuel pump is on to the tank where the electrical fuel pump is off may occur, especially at low engine power settings or when using the cross-feed in hotel mode. To cut the fuel supply to the engine, a fuel low-pressure valve controlled by the associated fire handle is installed at the fuel outlet of each tank. The fuel panel is located on the overhead panel. The pump push button controls the electrical fuel pump and the jet pump motive flow valve in each tank. Assuming that the push button is depressed, two conditions are possible. First, when the jet pump output pressure is below a certain value, for example, during the engine start sequence, the electrical fuel pump is automatically activated. The jet pump motive flow valve is controlled open, but remains closed until sufficient pressure is available. The other condition is when the motive flow is available and the normal jet pump is working properly. In this case, the electrical fuel pump automatically switches off. The green run light in the pump push button indicates that the electrical fuel pump is activated. If the push button is released, the white off light illuminates, the electrical fuel pump is deactivated, and the jet pump motive flow valve is controlled closed. The low-pressure valve position indicator displays the position of the respective fuel low-pressure valve, which is controlled by the corresponding fire handle. If the green flow bar is in line, the valve is open. In contrast, if the green flow bar crosses the system flow line, the valve is closed. The flow bar extinguishes during the transient phase of the valve. Next to the low pressure valve position indicator, you'll find the feed low pressure light. It illuminates amber, and the CCAS is activated when the fuel delivery pressure drops below 4 psi. It indicates a pump failure or fuel starvation. In case one of the feed low pressure lights illuminate and the corresponding electrical fuel pump is running, indicated by the green run light illuminated in the respective pump push button, you should suspect an engine internal fuel leak. The crossfeed push button controls the operation of the fuel crossfeed valve. When the push button is released, the green flow bar crosses the system flow line. The fuel crossfeed valve is closed. You'll find the correct fuel crossfeed procedure in your FCOM chapter, Procedures and Techniques. Assume you would like to use fuel coming only from the left fuel tank. First, you check that the corresponding run and off lights are extinguished in the pump push buttons. Then you depress the crossfeed push button and observe that the green flow bar is in line. Note that the blue fuel crossfeed light on the memory panel illuminates. Since both electrical fuel pumps are automatically activated, you must manually switch off the right electrical fuel pump. When the asymmetrical feeding is completed, you switch on the right electrical fuel pump, observe both green run lights illuminated, and release the crossfeed push button. Observe that the green flow bar is now crossing the system flow line again. Note that in normal operation, the flow bar extinguishes during the transient phase of the valve. In case of permanent extinguishing of both bars and the crossfeed push button is observed, it indicates a valve failure. The fuel tank capacity measurement system indicates the fuel figures in terms of weight. The measurement is based on the relationship between the dielectric constant of fuel and the fuel density. 6 probes are installed in each tank to obtain a signal proportional to the mass of fuel in the tanks. Each tank is equipped with an independent fuel quantity indicating channel. The fuel quantity indicator contains a digital fuel quantity indication for each tank. The envelope for acceptable accuracy of the total fuel indication is, on ground, a pitch attitude from -3 degrees to +1 degree, and a roll attitude of ±2 degrees. Within those limits, the accuracy is equal to 1% of full scale, quantified 1% of 2,500 kilograms, which is 25 kilograms near zero fuel level, or 3%, which is 75 kilograms at full fuel level. In flight, the fuel indication is only accurate if the wings are level, without side slip, and with a pitch attitude close to 0 degrees. Outside the accuracy envelope, the fuel indication is degraded. The fuel level in the feeder tanks affects the reading accuracy of the fuel quantity. The best reading accuracy is achieved when the aircraft is static, not moving, and the electrical fuel pumps have been running for more than 4 minutes to fill the feeder tank. If the quantity indication system fails on ground, you can still measure the fuel quantity. The correct procedure is described in the FCOM Chapter 2.06, Loading. Two magnetic level indicators are mounted in each tank through the lower wing skin. The roll attitude of the aircraft can be read on a clinometer in the hydraulic bay located in the left-hand landing gear fairing. The aircraft bank angle is considered positive for wing up and negative for wing down. The pitch attitude of the aircraft must be between -3 degrees and +1 degree, and within those limits pitch has no influence on the fuel quantity indication. The aircraft pitch can be obtained from the Electronic Attitude Director Indicator, EADI. Please refer to the chapter Flight Instruments for a detailed description of the EADI. Once the roll and pitch attitudes are noted, it is necessary to position an access platform below the wing and then manually unlock the manual magnetic indicators with a screwdriver. Slowly withdraw the rod until the magnetic attraction between the rod and the float magnets is felt. The next step is to check if the rod is free by pushing in both rod and float magnet and then releasing again until the rod is down to the floating level. Now, on the rod's graduation scale, just read the number aligned with the wing bottom surface. After reading, push it in and lock it with the screwdriver. Repeat the process for the other manual magnetic indicator and for the other fuel tank. Now you must use the fuel loading graph to determine the fuel quantity on board. Observe that this graph gives the results in liters and that each tank quantity must be determined separately. If both magnetic indicators do not show an extreme value, maximum or minimum value, you can disregard the clinometer indication when determining the fuel quantity due to accuracy purposes. In case only one magnetic indicator shows an extreme value, maximum or minimum, you shall disregard this value and use the clinometer indication and the other magnetic indicator value to determine the fuel quantity in that tank. Let's try some examples of how to use the fuel loading graph. Example 1. Internal indicator reading 17 centimeters, external indicator reading 0, and clinometer reading 1 degree high wing. Since the external indicator shows the minimum value, it can be disregarded. Enter the graph with the internal indicator reading. Then follow the corresponding reference line until reaching the vertical aircraft bank angle line corresponding to +1 degree. From this intersection, move horizontally to the left, and on the y-axis read the fuel quantity of this tank. In our example, the tank has 1,000 liters. Example 2. Internal indicator reading 19 centimeters, external indicator reading 6 centimeters, and clinometer reading -1 degree low wing. In this example, since neither indicator shows an extreme value, the clinometer indication can be disregarded. Enter the graph with internal and external indicators reading and follow the respective reference lines until they intersect. From this point, move horizontally to the left, and on the y-axis, read the fuel quantity of this tank. In our example, the tank has approximately 1,800 liters. Let's look at the fuel quantity panel located in the center instrument panel. As already mentioned, the fuel quantity indications display in kilograms the fuel quantity in each tank. To check both measurement channels, keep the test push button pressed while checking the following. If the functioning is normal, both quantity indications will display a sequence of the number 8s. Additionally, both low-level amber lights illuminate and the CCAS is activated. The master caution light flashes amber, a single chime is generated, and the amber fuel light illuminates on the CAP. The low-level lights illuminate amber when the measured quantity in the respective tank is lower than 160 kilograms. Furthermore, the CCAS is activated, and the associated electrical pump is automatically activated. Note that the low-level lights can only be tested by pressing the Test push button on the fuel quantity panel. Next to the fuel quantity panel, we see the fuel flow and fuel used indications. There's one indicator for each engine. The pointer of the fuel flow indication shows the fuel flow mass delivered at the moment to the respective engine. The scale is graduated in kilograms per hour multiplied by 100. The fuel used counter is a digital readout that indicates the fuel used in kilograms. The value is calculated by integration of the fuel flow parameter. If you pull the fuel used reset knob, the digital counter resets to 0. You can test all digits on the fuel used counter and on the fuel quantity indications by selecting the annunciator light switch to test position. 2 fuel temperature indicators, one for each engine, are installed on the main instrument panel. They indicate the temperature of the fuel delivered to the engines. In normal operation, the pointer shall always be within the green arc, ranging from 0 to plus 50 degrees. In case the fuel temperature becomes too low or too high, the procedures following failure checklist, fuel abnormal temperature must be carried out. Note that in case of a fuel abnormal temperature, the CCAS will not be activated. Therefore, continuous monitoring of the fuel temperature is necessary. 2 fuel clog amber lights, one related to each engine, are also installed on the main instrument panel. In case a significant fuel pressure loss is detected in the corresponding high-pressure pump fuel filter, the CCAS is activated. The master caution is activated, along with a single chime, as well as the amber engine light on the CAP and the corresponding fuel clog light. This situation indicates that the respective fuel filter is blocked and has been bypassed. The refueling panel is installed in the right-hand main landing gear fairing. This panel allows you to control all refueling or defueling operations. You can refill the tanks in approximately 16 minutes through the single refueling connector. The connector is located on the rear part of the right-hand main landing gear fairing. The tanks can be refueled with a maximum pressure of 50 psi. From the refueling connector, the fuel flows to the refuel valves and then into pipes to diffusers, which allow the fuel to enter the tanks without surging. During automatic refueling, the tanks are filled simultaneously. Observe that refueling the aircraft with the right engine running in hotel mode is prohibited. High-level detection consists of 2 different controls. Normally, the fuel quantity indicator system detects when the high-level quantity is reached in the tanks and closes the associated refuel valve. In case the fuel quantity indicator system fails, a level sensor installed at the bottom of each surge tank detects the high level. When the sensors detect high level, the associated high-level light on the refuel panel illuminates and the refuel valve is shut. Both tanks can also be refueled by gravity via a dedicated wing filler cap for each fuel tank. The correct procedure can be found in the FCOM Chapter 2.06, Loading Fuel Balance Chart. If the aircraft needs to be defueled, a maximum suction of 11 psi should be applied to the connector and the tank refuel valves must be opened manually. Press and hold the Fuel Quantity Indications test push button to check the measurement channels. If the channels are functioning normally, both quantity indications, on the refueling panel and in the cockpit, will display a sequence of 8s. Furthermore, all refuel valves shut, simulating a maximum level in the tanks. Additionally, the CCAS is activated. Let's have a closer look at the refueling panel. The high-level light illuminates when the maximum fuel quantity is reached in the respective tank. In this case, the associated refuel valve automatically closes. The refuel valve position light illuminates blue when the refuel valve is open. During the fuel circuit test, if those lights are illuminated, they will extinguish because the refuel valves are forced to shut. The high-level lights and the refuel valve position lights can be tested by pushing the respective light on the refueling panel. The refuel valve switches control the operation of the valves for the respective tank. They are normally guarded at normal position. The automatic fueling logic controls the valves in normal position. The automatic fueling logic depends on the position of the mode selector switch and the fuel quantity pre-selection. By manually placing the refuel valve switch to the open position, the respective refuel valve will open if the mode selector switch is moved to the refuel or defuel position, and the high-level limit is not reached. At position shut, the valves close irrespectively of the mode selector switch position. You can pre-select the quantity for automatic refueling by setting the pre-selector. The pre-selector is composed of 4 drums indicating from left to right, thousands, hundreds, tens, and single units of kilos. Observe that it's only possible to pre-select the thousands and hundreds of kilos. The last 2 pre-selector drums are fixed, always displaying 0. The fuel quantity indications display the actual fuel quantity in each wing tank as the cockpit fuel quantity indications. Once the refueling panel door is opened, the fuel quantity indications will automatically turn on. Wait for the indications to become stabilized before taking into account the total fuel on board. The mode selector switch allows the operation of the automatic refueling or the operation of the manual refueling or defueling. In the position off, all refuel valves are closed regardless of the refuel valve switch positions. At position refuel, the refuel valves are automatically controlled by the auto refueling logic if the refuel valve switches are set to normal. Also, the refuel valves can be manually controlled by placing the refuel valve switches to open or shut. If the mode selector switch is set to defuel, the refuel valves are controlled only manually by selecting the refuel valve switches to open or shut. Be aware that once the mode selector switch is set to defuel and the refuel valve switches are in the open position, all level protections are inhibited. A surge valve provides air ventilation to the refuel line during suction draining of this line. A guarded toggle switch, normally set to the position shut, controls the surge valve. Once the switch is set to the position Open, the surge valve opens only if the mode selector switch is set to Off. In position Shut, the surge valve remains closed. Imagine that you would like to refuel your aircraft with 1,700 kilograms of fuel by using the automatic refueling logic. First, be sure that the fuel truck and the aircraft are properly grounded. Open the refueling panel door and perform the fuel quantity indications test. Check that the refuel valve position switches are in position Normal and guarded. Check that the mode selector switch is in position Off. Check the surge valve switch in position Shut and guarded. Thereafter, pre-select the required amount of fuel. To start the refill process, move the mode selector switch to position Refuel. Supervise the refuel process. Observe both refuel valve positions' blue lights illuminated. They will automatically extinguish when the correct fuel level in the tank is reached, thus indicating that the refuel valve is closed. When the process is completed, check the actual fuel quantity. Select the mode selector switch to Off and close the refueling panel door. In this chapter, we'll discuss the possible alerts related to the fuel system of the ATR. 3 conditions lead to an alert. If the engine feed pressure drops below 4 psi, or the jet pump pressure drops below 5 psi, or the fuel quantity in one of the fuel tanks is below 160 kilograms. Assume that the engine 1 feed pressure drops below 4 psi. The following alerts will be generated to warn the flight crew about this problem. The master caution light flashes amber. The fuel light on the CAP illuminates amber. The associated feed low pressure light on the fuel panel illuminates amber. And a single chime sounds. Consult the QRH for the correct failure handling. Now assume that the pressure at the jet pump output drops below 5 psi. Remember that in this case the associated electrical fuel pump is automatically activated, thus assuring the engine fuel supply. You can only recognize this condition by looking at the fuel panel. The green run light illuminates to indicate that the electrical pump is running. Let's have a look at the fuel quantity indication. If the quantity in one fuel tank is below 160 kilograms, the master caution light flashes amber. The fuel light on the CAP illuminates amber. The associated low-level light on the fuel quantity panel illuminates amber, and you hear a single chime. Consult the QRH for the correct failure handling. This lesson will help you to become familiar with the electrical supply of the fuel system. All components are supplied by one of the DC buses. DC Essential Bus. DC Bus 1. DC Bus 2. DC Emergency Bus. Ground Handling Bus. Note that the fuel quantity indications will be supplied by the ground handling bus for airplane servicing on ground when the battery is off and the refueling panel door is opened. On the right maintenance panel, you can find a readout display for failures of systems linked to the MFC. It can be used to test the feeder jet pump's functioning.